start then.
Okay. Should we start from, okay. Well, here are the slides. Okay. So odometry is a class that we use, and it takes the readings from the encoders and the gyro to calculate where the robot is on the field. So as you can see here, this is a picture of a path. And what it does basically is that it takes this path and divides it into vectors and takes the x and y, so then it can figure out the x and y coordinates and also the angle.
And so another concept is Ramsete controller. Basically, it takes in the pose and the trajectory to calculate linear and angular velocity. So it can be 1 meters per second or 0.2 radians per second. So that's linear, and the second one's angular velocity. Basically, it's a curve. And so what this Ramsete controller does is it's basically a closed loop controller similar to PID. And so if you give it a starting value and a PID controller, it returns adjusted velocities. And that's how you get from your start point to your set point. So let's say if you just want to go straight by like a meter, you generally deal with metric constants in autonomous stuff. So if you want to go for a meter, your adjusted velocity for left and right should be 1.0 because you just want to keep going forward. And towards the end, maybe it slows it down because you want to gradually come to a stop.
And so kinematics is another class that we use. It's basically a physics concept related to motion, and it takes those linear and angular velocities and it calculates the left and right motor speeds in meters per second.
Okay, so PID controller and voltage again. PID comes up a lot, but basically you give PID controllers the left and right velocity along with other PID constants and the feed forward constant. And these controllers, they do what they have to do. So compensate for any errors, give feedback to the motors, and ultimately Ramsete Command uses this PID controller to run its path or the trajectory that you give it.
So that was a lot of information. Do you guys have any questions?
What was one of the first on the first slides, like gyro, something?
Okay, so basically a gyroscope is a component that we have on the robot, and it's what we have. Our model is NavX, and it basically just takes the direction of the robot.
Like angles.
Yeah, like angles. Yeah.
It's the thing that you have in your phone also, and like the one we have on the robot is a 9-axis gyro, so it's really accurate. It tells you which direction your robot is facing, X, Y, and Z. So length, width, and height.
So like 0, 0 would be like how
just like forward, and then every time you turn, it would track that, and it would give you a direction if you ask it. Yeah.
Oh, okay. So like every time you start, then that straightforward is 0, even if you. Okay.
Yeah, like you could look at the code and in robot init, when it starts, it resets the gyro. So, or it resets the odometer. All right. Are there any other questions?
No? So the Ramsete command is like, it uses the PID controllers, and then wait, so like yeah.
So you'll see. We'll what we're gonna do now is we're gonna look at it in code. We're gonna give you some like documentation, and you guys will be able to see it like on your screen. So it will hopefully be a lot clearer. But so these are some questions that we want you guys to look at. So 1, how do you create an odometry and the odometry object, and what are the parameters? 2, where and how do you update it? 3, how is this image on the right related to an S-curve? So this is basically a list of waypoints, and your start and end points are there. And 4, where is it calling drive on drive face? So I'll give you guys the links to the documentation, and you guys can see what it looks like. I'll also show you. Okay, so this is the second link. You guys can see it, right? Yeah, okay. So this is the second link, and you can see here, this is the Ramsete command that we're looking at. So this is the command. It takes in a trajectory that is made from a list of waypoints and poses. And then it takes in, and then it gets the pose, and then you have your Ramsete controller. And you can see here we have our PID controllers. So that's where it is. This is in the autonomous command.
Oh yeah, what is the posing?
Get pose. So this gets the current pose of the robot so that it can make calculations of where the robot should go next.
And the pose is like is when the curve is like split into vectors.
Pose is in X, Y, and angle. So that's like that's basically what it holds. So pose is basically position of the robot.
It's just like encoders combined with the gyros.
Pose is just XY. So at this second, I am at this XY. And so that's what it's going to return.
So it like, and then it's like, so when you start the robot, 0, 0 is where it currently is.
Yeah, and then it moves every second, and so pose is changing, and this get pose just returns that pose.
Okay, so it's like position.
Yeah, pose is
okay.
So yeah, I'll go back to the slide so you guys can see the questions. Oops.
This example is does the drive subsystem extends the subsystem base? What exactly is a subsystem base?
Okay, I think the question was about subsystem versus subsystem base, right?
Yeah.
Okay, we kind of made a new system last year, which was basically for managing health of subsystems. And so subsystem is the original class that WPLib has. Mustang subsystem base is the class that we made over their class, which specifically tracks health. So it's all the same thing, but it's just an additional feature that we made.
But WPLib has a subsystem base.
Yeah.
Oh, okay. Okay. And what does the periodic method do again?
Gets run like repeatedly, right?
Yeah, so basically the periodic method is just being called constantly while the robot's running.
Oh, okay.
Oh, did this chat show on the screen?
Wait, are we supposed to answer the questions? Like,
Yeah. So are you guys done? Have you guys all looked at it?
Except for 4.
Sorry?
Oh wait, should we start? Like saying what the answers are?
Yeah, go for it.
Okay. Well, I found there's a differential drive odometry class. And you make an odometry there, and then you update it in periodic.
Okay.
oh, okay. Well, I said like you like create a new like differential drive odometry object, and then you pass in like the rotation of the gyro or something like that. Yeah, like that line.
Yeah, so it's in the drive subsystem. It's in the drive base class. And yeah, like you said, you take the rotation of the gyro.
And then like, would you update it in oh wait, where is it? Would you update it in like reset odometry?
That would reset the
Then you would
odometry.
update it
So
in.
Oh,
So reset is
yeah.
0, but periodic is where you would update it.
Yeah,
Oh,
it says right here, odometry.update. So yeah, at least mention this one too. You would basically just be constantly updating the odometry, getting the rotation of the robot, and also getting the velocity or the distances of both encoders. And then how is this image on the right related to S curve?
I said that the list is like the components, the vectors of the curve.
Yeah, okay.
yeah, like is it like the points where like the curve like changes? Like I don't know how to explain it, but like the points where the like direction or like the rotation changes, sort of.
Kind of. They're basically just waypoints. You're basically telling the robot, okay, if you, wait, hold on. If you go back to this one, then you look at the example trajectory right here. You're basically telling it, okay, so you're starting at 0, 0, right? And you're facing forward. And I want you to go through these 2 waypoints. Like, it doesn't matter how you get there, just go there and be like efficient. And then I want you to end at 3, 0, and I want you to be facing this direction. So yeah, you guys basically got it. You guys were a little more specific, but yeah, you guys got it.
Well, just one more thing about it. What's the x component? What's the y component to those waypoints? So is it like a vertical S or a horizontal S?
Wait, what were the wait?
Oh, they're right here. We can go back to slides right here.
It's like sideways, right? It's like going like
Yeah.
that.
Horizontal.
So did you take x, y?
Oh wait, no, never mind. Sorry, I meant horizontal, I think.
Okay, so you guys are saying horizontal. That's what it should have been, but what WPLib did was they actually switched it. So this is y, that's x. So technically, if you look at this, that's 0, 0. Let me change my. Okay, that's 0, 0, and then it says 1, 1. So that's go up by 1 and then right by 1. So first one is y, second one's x. Then go up by 1 again. So it goes up by 1 again, and then go to 0, and then to -1. So that's where it goes. And finally 3, 0. So that's another up, and then back to 0. So this is how it's going to do it.
This is in meters, right? And it says 1, 1, and then 2, -1.
Well, the waypoints are in just regular geometry. The meters are actually these ones, and then you can also set like a factoring point. You can multiply it by a factor of 2. Yeah.
Okay.
So ultimately, this is a 3-meter path in an S shape.
So the center one would be 0. Right? If you want to go straight, you would just have it 1 point, which is just 0, 0.
You would just have a start point and an end point. If you want to make it more accurate, maybe you also give it a waypoint in the middle. So maybe 0, 0, 2, 0, or 1.50, and then 3, 0. And that's how you'll do it.
But like, so normally instead of just hard coding the numbers, why, like, I guess how would this, so does, wait, how do I say this? Like, how would that be useful? Because like, you have like the controller, right?
Mhm.
But isn't it like, does that mean that we all like part of the code is coding the controller, like the oh wait, now it sounds really dumb. It's like basically how do I okay.
So I think what you're getting at is, why do we hard code like these numbers?
Well, why is this like, shouldn't the code to move the robot, like, isn't that already like done? Is that like,
Well, okay, so there is something to control the wheels of the robot. That's tank drive. That's the most basic one. Then there is simple distance drive with PID that you could do. But then when you want to do complex curves that are accurate, and also like you want to go over bumps. So we had some bumps this year in the game on the field. And so that's when you apply this. And specifically getting to where do we get these numbers? Like, aren't these numbers technically also hard coded? The answer is no, and that's actually the next concept. There is a software on which you just draw paths, and then that generates these numbers for you, including the whole code for your path. So it'll make all the waypoints that you have, and then you just copy paste it, and that's how it works.
okay, I was trying to figure out how to go from like controller to this point. Okay.
Cool.
And then your last question, where is it calling drive on drive face?
Is it arcade drive?
No, because arcade drive would be a teleoff thing. We're doing.
Oh, okay.
Is it in the command? It's the last one of the command, right?
Is it a command? Yeah, it's a command.
It's
Well,
an
it's a method, yeah.
yeah. It's saying am robot drive dot think drive volts and it's saying 0.
Yeah, that's it. So wait. If you go over here, so this is the autonomous command and robot container. And then you have your Ramsete command. This is the thing that compiles and does everything basically. And here you have robot drive, tank drive volts. So as we mentioned before, this basically just gets the volts that like it calculates. So Ramsete command calculates the voltage and it basically just gives it back to the tank drive. And this can be shown in the drive subsystem right here.
Could you also just go back to the command again? Just one more thing. Java specific. I don't know if you guys have used it, but these are Lambda functions. So basically, what it's doing is it's saying in the mRobotDrive object or the class, go find the method which is named tank drive volts and then use it.
So it's calling the method.
Exactly.
How is it passing arguments? Doesn't
That Lambda functions, they directly pass in stuff. You just have to give it the method name. It finds out the parameters for itself, or something's happening in the back of the Ramsete command.
Oh wait, this is
Okay.
not in Java.
This is Java.
Okay, right. So then why would it? Can't it just like object dot? Like, I was like, so why can't you just do object dot?
Because it's a constructor. So you can't call a method inside a constructor, and that's the reason you do Lambda.
And so it allows you to call a method. Okay.
So basically, indirectly what's happening in the actual constructor inside the Ramsete command class is whenever you give it like a Lambda command, it stores it somewhere. And then when it has to call it finally, it gives it the parameters and also calls that method name. And that's how it works.
Great. Any other questions? No? All right. I guess that's it then.